All right, this is section 4.6 about rational functions and models. First, what is a rational function? So a function f represented by f of x equals p of x over q of x, where p of x and q of x are polynomials, and q of x is not 0, is a rational function. Its domain is the set of all x such that q of x is not 0. Again, notice q of x is the denominator, so it cannot be 0. This excludes values of x where q of x is 0. Okay, so determine which are rational functions and give the domain of each. Let's take a look at a little bit closer here. All right, so again, it's in the form of a fraction, but to be a rational function, the top numerator and denominator both have to be polynomials. We look at number 1, they are both polynomials, so therefore this is a rational function. This is a rational function, so I'm going to say f is a rational function. And then the domain, so I just need to check where the bottom will be 0, because those values have to be excluded from the domain. I would write x squared minus 2x minus 24 equals 0. Notice that really what I'm going to check is where is it equal to 0 so that I can exclude those. This is minus 2x. I think I can factor this as x minus 6 times x plus 4. X squared minus x. Yep. And so remember your zeros factor 0, so x minus 6 is a factor, so x equals 6 is a 0, and x equals negative 4 is a 0. So my answer is x cannot be 6 or negative 4. Okay? Just be aware in your book, the book will sometimes write it like this, as the set of all x such that x is not 6 or negative 4. And what it means is that they're telling us that any real number except 6 or negative 4 can be plugged in place of x. Let's try the second one. So this one, the top is a polynomial, but the bottom is not. Polynomials do not have square roots around them. I don't know if you guys remember the form of a polynomial. So this is not a rational function. Not a rational function. Okay. What is the domain? Well, the bottom cannot be 0, and that'll happen when the square root, when the x plus 5 is 0, right? But also, x plus 5 has to be greater than or equal to 0. It cannot be negative, because you can't take the square roots of negatives as far as real numbers are concerned. So what we want to know is, where's x plus 5 greater than 0? Yeah, remember, it cannot be 0 because your denominator cannot be 0. So we solve, we get x is greater than negative 5. Okay? And just the difference is, in your book it might be written the set of all x such that x is greater than negative 5. Okay? All right. Whichever way you write it is good, for as far as I'm concerned. I'll let you do number 3, or we'll do it in class. All right, let's try look at vertical asymptotes and horizontal asymptotes. What are they? So the line x equals k is a vertical asymptote of the graph of f. If f of x approaches infinity, or f of x goes towards infinity, or f of x approaches or goes to negative infinity, as x approaches k from either the left or the right side. K will be some number. Okay? Remember, this is a line. The line x equals k. So we have to give the answer in this form. X equals something. And where it says f of x approaches infinity, or f of x approaches negative infinity as x approaches k, that means you have some vertical line, and as you approach it from the left, your graph starts following the line upward or downward, and it just follows the line and follows the line. It's getting forever closer and closer, but it never gets there. Or from the other side, same thing. Getting forever closer and closer, but never gets there. I look at it as it takes off upward or it takes off downward, whichever way. That's the way my graph will look when it gets to that line. Okay, and the line, it may be shown or not shown. Okay, so sometimes you just see the graph going like that, and you determine what that line looks like. All right, it does have to be vertical, right? Horizontal asymptotes, similarly, it's just going to be a horizontal line, so it'll have equation y equals something. Is a horizontal asymptote of the graph of f if f of x approaches b as x goes to infinity or as x goes to negative infinity. X goes to infinity means you're going all the way to the right, or x goes to negative infinity means you're going to the left a long, long ways, right? Or forever to the left. And f of x equals b means you're following a flat line, a horizontal line, okay? So it's similar to what we saw up here, except it's going to be a horizontal line, and your graph is just going to flatten out, right? Flatten out, or flatten out from one side or from the other, right? It's going to flatten out and start following that line. It never, oops, I think I'm not showing you. It never gets to touch the line, but it follows it, and it looks like it touches it. It just never does, okay? All right. Notice this refers to a graph, and we'll see later on what happens if we get one like this. This is a rational function. What happens if we get a function like that? How will we find where it has asymptotes, or does it have asymptotes? All right, so let's look at number 4. So we'll look at vertical and horizontal asymptotes. I will abbreviate vertical asymptote VA and horizontal asymptote HA, just so we know we have to answer 2 answers. Okay, a horizontal asymptote and a vertical asymptote. Okay, so vertical asymptote is a vertical line where your line starts following that line. I'm sorry, where your graph starts following that line. It looks like that line is here. Yeah, right there at x equals -4. So the equation of the vertical asymptote is x equals -4. For the horizontal asymptote is a flat line where that's happening, right, where the graph starts following that flat line. And that looks like it's here. And that looks like y equals -2. Yeah, so that's my horizontal asymptote. Okay, I'll leave you guys to do number 5 in class. All right, and let's continue. So what happens if we do have some rational function in symbolic form? How do we find vertical and horizontal asymptotes if we can't see the graph? Well, we go in the following way. So first, we want to factor numerator and denominator and make sure f of x is in lowest terms. That means cancel any factors that are the same. If x minus k is a factor of both, then exclude x equals k from the domain, yeah, and reduce. And then, number 2, to find the vertical asymptotes, if q of k equals 0, that means if k is a 0, then the line x equals k is a vertical asymptote, if k is a 0 of the denominator. To find the horizontal asymptotes, you look at the degree of numerator and denominator. If the degree of the numerator is less than the degree of the denominator, that means the degree of the top is less than the degree of the bottom, then y equals 0 is a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then y equals a over b is a horizontal asymptote, where a is the leading coefficient of the top and b is the leading coefficient of the bottom, right? And then if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. Okay, so let's try number 7 and 9, and we'll leave 6 and 8 for class. All right, so number 7. So first I'm going to try to factor and see if anything cancels. The top does not factor. The bottom factors a little bit like so, but nothing cancels. Okay, so that means that's I keep the same factors and all the terms. All right, so for a vertical asymptote, I need to find any 0 of the denominator. And you can see a factor is x plus 2, so a 0 is x equals -2. If you want to have a way of approaching this, just set the bottom equal to 0 and solve, and you'll get x equals -2. Horizontal asymptotes, we look at the degrees of top and bottom. I'm going to look at the original expression. It's easier to see the degrees. The degrees are 1 and 1. The degrees are the same. So therefore, this is an example of criteria B, right? This says if the degree of the numerator is the same as the degree of the denominator, then y equals a over b is a horizontal asymptote. A is the leading coefficient of the top, and b is the leading coefficient of the bottom. So this will be y equals leading coefficient over leading coefficient, 3 over 2. Remember, this is only when the degrees of the top and bottom are the same. All right, and let's try number 9. So again, I'm going to factor. I can factor out in 8 from the top. And the bottom is x minus 2 times x plus 1. Okay, so notice x plus 1 is the same top and bottom, so I'm going to say x cannot be -1. And if I reduce that out, that leaves me 8 over x minus 2. Okay, so vertical asymptotes then. X minus 2 is a factor, so x equals 2 is a 0. Yeah? And horizontal asymptotes, I look at the degree of the top compared to the degree of the bottom, and I can look at the original. Okay? That'll be x 1 over 2, so the degree of the top is smaller, so y equals 0, right? That's what it says up here. If the degree of the numerator is smaller than the degree of the denominator, y equals 0 is a horizontal asymptote, so y equals 0 is a horizontal asymptote. Okay, I think that's, the last part is just an application, so we'll look at it in class, okay? All right, and that's it for section 4, 6.